parts and pieces in place. We have talked about the power source, the pump, hooking up to the battery, the solar panel. Once we get the tank that we're currently working on sanitized, bringing the chlorine levels up to anywhere from 2.5 to 3.0 parts per million, we are going to stop the process, and then we have to move the chlorine generator and the pump assembly to the second tank that is also full of water. That is going to require moving the solar panel, the power source, the pump manifold, and the M100 and the hoses down to the second tank. What this will do is give us time to have contact of chlorine to water in this tank. Remember, the water source was a lake, a stream, a pond, maybe came through a municipal pipe, possibly it was delivered by the fire department. And so we've chlorinated, we have 2.5 to 3.0 parts per million. That gives us time to go set up down here and start the process here. By the time the process is finished down here with chlorination, this tank will be ready for distribution. So tank number 2 is filled up with water, and we have moved the pump manifold and the M100 and its hoses down to tank number 2, clip them back in with the cam lock fittings, making sure everything's locked into position. Our solar panel, we've moved it to this location as well. We're hooked up to the battery, and we can go ahead and start the process of chlorinating water in this tank through circulation. Introducing chlorine gas into the water, bringing it up to 2.5, 3.0 parts per million, and then stopping the process when we reach that place. So now what we have is 2 tanks of water. Again, keep in mind these are only 500-gallon tanks. Typically in a system like this you're going to be using 1,250-gallon tanks. That'll give you 2,500 gallons of water available to disperse in an emergency situation. The process for a tank 500 gallons or so is going to take about 18 minutes to chlorinate the water in there to bring it up to 2.5, 3.0 parts per million. A larger tank, like the 1,250 gallons, they're going to take somewhere probably around 20 minutes. Once the system is rolling, each tank after that will probably be reduced in half by that. A 500-gallon tank down to 9 or 10 minutes, and a 1,250-gallon tank probably down to about 12 or 15 minutes. So the process goes faster as the chlorinator generates, and so now you've got 2 tanks. It's chlorinated, and it can be dispersed and used for emergency drinking water. You're going to want to have some contact time. Talked about that a little bit. The World Health Organization recommends contact at 2.5 to 3.0 for 30 minutes. As long as you have contact at the end of 30 minutes, you're still at 2.5 to 3.0 parts per million. The water is safe to drink. And you may not like the looks of it, but in an emergency situation, it'll be okay. I'm going to demonstrate a couple of different ways that the hand pump can be used to move water out of the tank through filtration, through a couple of adapters we have here, and or how we can fill the tank utilizing the filters on the front end. There's a couple of different ways we can do this. If we don't have the time to filter on the front end, which means as we pull water from our source into the tanks and filtering it prior to chlorination, we can do it afterwards if we find that there's particulate in the water. I'm going to demonstrate that one first, and then we'll go to how we can utilize a municipal water source or a fire apparatus, a fire hose, to hook into the system and fill the tanks up. So first what we're going to do is we're going to take the pump. If you'll notice that there's another opening that we utilized. This tank has been filled, it's been chlorinated. We've moved down to tank number 2. We've had contact time of at least 30 minutes. We don't have a power source available to us at this moment. For example, the 115 volt minimum power source that we would need to run the pump is not available right now, and we've got to get the water out of the tank because there's people that are needing to get some water. What we can simply do is identify the inlet side of the pump, which is written on the pump itself. It says inlet and outlet, and when it says inlet, that means that that's where the water is going to come into the pump. Since we're coming out of the tank, we're going to hook directly up to this line. We're going to open up this valve. This gives us water out of the tank and right up into the pump. Now, since the pumps are sitting on the ground, we wouldn't be able to get water out of them that easy unless we pump it out. So what we've done is we've got a hose connection that can be hooked with an adapter right into the outlet side of the pump. We hook in. We can now actually pump water out, and we can control what we're filling it into by pumping the water. Just pump, pump, pumping away. That's one application. If we're sitting here pumping the water away into a container and we find, man, that water looks pretty dirty, we may have to think about filtering it. What we would do then is we can take the hose assembly loose, bring the filter in line, hook it into place, come back off. Now we can still pump, pulling water out of the tank. It's coming through 100 microns down to 25 microns, and now we're filtering the water as we're pushing it through into the containers to be filled. This is one option. Since we just found out that the water that appeared to be clear or free of some particulate has already gotten into the tank, we've pumped this out. What we're probably going to want to think about on the next time around is when we fill the tanks, whether it's from a municipal line, which could require us to use a hose. For example, if you had a place for a hose connection at the place that you were set up, you'd be able to hook the hose to this with an adapter here. You'll be able to hook directly into your filters. So we found out that we had water. Our water source was less than clear with particulate or turbidity. We found that out when we started to move water out of the tank. We chlorinated it, sanitized. It is safe to drink, but it doesn't look so hot. So what we may want to think about from this point on is, because we're probably going to be getting our water from a source, from the same source each time, we're going to want to make sure that we filter it when we fill the tanks. So with the help of an adapter and the RV hose that comes with this, what we'll simply do is connect our adapter to the hose, hook it into the filter, run our hose back to the source, which could be a hose connection on a building or a tanker truck, whatever the case may be. And then what we'll do is we will filter the water actually going into the tank. by hooking in like this. So water's coming from our source, whatever that may be. Could be building water supply, municipal water supply, fire truck, through the hose, through 100 micron disc filtration, 25 micron disc filtration, and filling up the tank. So at this point, next time around, on the next round of filling the tank, we won't have the problem of non-clarity of water. So we can filter going in, we can filter coming out, we can use a hand pump to get water out of the tanks, utilizing all of the same parts and pieces. Everything that you've seen so far is included with the mobile water system. This is a shallow well jet pump with a bladder tank and pressure switch. What that means is that if we have a power source, 115 volts, whether it's coming through an outlet or coming off of a generator, we would be able to pull the water out of the tanks, either left tank or right tank or both tanks at the same time if we needed to, and distribute the water through these different outlets. These are convenience outlets that are added into the system. They're regular garden hose connection. They're valved individually so that water can be distributed out of these through a hose to a manifold system or tied back into a building. For example, you can make your hose connection. You'd be able to take the adapter that comes with this. You would be able to come off of the system and tie back into a building or another source that you wanted to distribute the water through. You have two openings to do that through, and how that works is the way a jet pump bladder tank pressure switch system works is that when there's a demand for water, for example, if you had this hose hooked into an emergency trailer that was supplying water and food for people to eat, the only time that the pump would run when it was connected to its power source would be when there was a demand for water. An example, if somebody opened a faucet or opened a series of bottle fillers or drinking fountains or hand wash stations, whatever the case may be. When the faucets were turned back off, the pump would automatically turn off. With the system, you get 25 feet of heavy-duty extension cord and a ground fault interrupter, a GFI. This would hook into your power source first. For example, if we had a generator running, we would plug this into the generator, and then we would plug our extension cord into the ground fault interrupter, and then we would plug our pump into the power cord. This will give our pump power to run when there's a demand for water. Once this pump is up and running, the water that we chlorinated in the first tank and the second tank is now being pulled through the manifolds, through the hoses, and into the pump. So chlorinated water from the tanks is now moving in this direction into the pump, and now is being distributed out by a power source and a pump through a hose or a piping system or whatever you need to get the water from point A to point B. So as a recap, if you have a power source, that would be energy coming through outlets on the wall or the grid, or you have a generator to generate electricity, this would be your distribution system. If you have no grid and no generator, or your generator's failed, you're out of gas, you've got sanitized water in the tanks, what you would do is use the hand pump to get the water out of the tanks.